What's up, Alchemist? Welcome back into the channel. I'm Tom, the Full Data Alchemist, and today we're diving into the world of data manipulation libraries in Python. Specifically, we're going to be comparing pandas and polars. And whether you are a data analyst, a data science enthusiast, consider yourself a data alchemist, understanding these tools can help you handle data more efficiently. So let's just jump right into this and actually compare the two different libraries. As you know, Pandas has been the go-to library for data manipulation in Python for years. It's known for its flexibility, comprehensive features, but there's a new kid on the block. And that new kid is called Polars, which promises high performance, especially with larger data sets. But we're going to jump in and look at Pandas first. As we know, it's feature-rich, integrates seamlessly with the Python ecosystem, and is backed by a massive community with tons of support. But it can struggle with performance when dealing with very large data sets. So let's take a look at this. We're actually going to be messing around with pandas and polars, using this in a Jupyter notebook inside VS Code. The first and very most thing before we actually load any of this data, we have to make sure we actually have pandas and polars installed. So we're going to go ahead and do pip install pandas. That's going to install pandas for us. And go through this, install it. It's going to install a bunch of dependencies and a bunch of other different things for us. And then it'll install, and now we have pandas installed. Then we're going to go ahead and install polars, pip install polars. And I'll go ahead, boom, now we have both of them installed and we're ready to go. So how do we use this now? Well, sometimes you may actually have to just restart this. So if we type in import pandas, initialize, sometimes you might see pandas underlined, meaning it can't start it. It's not loaded. You may have to close out of your VS Code or any other IDE that you're running and reboot it so it can recycle and look at and find the libraries you have just loaded. We're going to import pandas. We're actually going to give pandas an alias as PD. And now throughout your application, pandas will be known as PD. So anytime you want to access pandas, you'll use PD instead of typing out the word pandas consistently. We're going to do the same thing with polars. We're going to do import polars. I keep calling it polar. Import polars. I'm going to give this an alias as L. Alias is just telling the system what you want to call it. You can make this for peanut butter and jelly for all you care. But for simplicity's sake, we're going to make it short and sweet just so we can easily type out two character call to pandas instead of typing out pandas every time we want to use that library. Now we're going to go ahead and use our data frame. I actually have a CSV file of all COVID deaths over the years that we're going to be playing around with, all the different countries, and a bunch of different data sets that we're going to be looking through and playing around with. So we'll go ahead and close this out. We can't have that file open and running while we're trying to access it through pandas or polars. It will bark and complain to us because we have the file open. So the first and foremost thing, I'll show you how to actually load a data frame into pandas. We're going to do df is assigned to. We'll then call our pd.read CSV because our file is a CSV. And then we have to look at our name and we have to find it. What was the name of that file? OWID. We could just do a copy. We could just actually probably do this too. Copy, rename, and drop it in there. Normally, sometimes a IntelliSense will pop up and find the actual name for you, and you can go ahead and read it. Well, there's two things we could do here. We can actually print this out and do a full display of the full file, or we could use something called head, which will give us the first 5 rows of the data frame. So we'll go ahead and say we'll do this first. We'll do I like to use display display.df.head. So this is just using this makes it look nicer instead of using print. So we'll run this block of code. Might take a little bit because there's a lot of code there, and boom, prints out nicely. I like using display because it prints out this table very nicely. Or print doesn't do that. Print gets very messy. We do print df.head. We'll get both, and this is what print does. If you're working Jupyter notebooks, I just happen, especially in VS Code, I like to use display. It makes it look nice. It makes it like an HTML format, and you're easy to read it. Now, polars, we'll do the same thing. We'll do df equals pl.read CSV. We'll read in our CSV file, and then we'll say display df.head. Same syntax, pretty much. The only thing that changed right now is the PL. And then we'll hit run. And we'll get that. So this actually took 0.7 seconds to run versus 0.25 seconds to run. Interesting. Maybe because it was already cached. Look at that. Already cached. Ran it pretty quick. Didn't even take any time. Let's run this again. Still took 0.7 seconds. Once it's cached, it's much faster. So little things that with noticing, I haven't really used Polar, so I'm playing with it and we're learning together as you go through this. So if you see down here, it shows us that we have, 5 rows right now and we have 67 columns. So let's right off the bat. What Polars does different is telling you the shape or the rows and columns, or the shape of the actual data frame that we're looking at is 5 rows and 67 columns. So that's one thing that this does different in terms of displaying information. So if you're not sure, if you see this in anything you're doing with Python and messing around with columns and rows, data frames, spreadsheets, and you see shape, X and Y, or a number and a number, that's going to be your row, that's going to be your columns. There's going to be your first number and your second number, just so you know that. That is Polars, and that is how you actually look at them. The syntax is really not that much different. So we saw how we read in it. We saw how we read in a CSV and how we print out or display a CSV. But what if we actually want to start seeing, filtering out data? So let's make a variable inside of for pandas called filtered df, and that filtered df is going to be assigned to the df. We're going to filter on the df again, and we're going to filter on column name. Let's filter on, I don't know, let's take a look here. Maybe we'll filter on total cases. So let's look at total cases. So we'll look at these. I'm noticing something else here too as I'm looking at this. What's nice about this is it's actually telling you what data type the column is. So this is nice. So IS code, it's a string. Continent, it's a string. Total cases is float 64. Everything else needs to be a float 64. So that's pretty cool. So now you know right off the bat that you're going to see this and it's a string, it's a float, it's a string, it's a float. You know what type of data you're messing with as soon as you're looking at it without having to, do a type. So we're going to do df, and we're going to say the column name is going to be df total cases. And your columns, your column names and pandas and in Polars have to be exact match. If you do total cases like this and you try to run it, it's going to fail. It's going to tell you there is no total cases that exist within within the file, within the data frame. So it always has to be case sensitive. All your columns are always case sensitive. Same thing with your values. They are case sensitive. So column name, and because these are nan, not a number, we may have to filter this out differently. If we were doing new cases and it was 0.0, we could probably say, less than 0. And then we need to say, I believe is dot not NA is what we want to see. And then we'll close this off. Then we can do display filtered df. Then we'll go ahead and drop this out. We don't need to see this one anymore. We will then go ahead and run this. And now we don't see any more NAs. There's no more .nn. And we're getting, and what's happening here, because we dropped the display.head, we could actually do .head here if we wanted to. What's happening is that we are seeing the first 5 rows. And then this is telling us that there's more data in between all that, but we're getting the last 5 rows as well. So as you can see, there's total cases 1, 1, 1, 1. And then by the time we're in 2024 in Africa, 410, just about 2 weeks ago, here's Africa and here's the no NA. So this is now showing us nothing with no NAs. We filtered that out. And we can do the same thing with Polars. We'll comment this out. We'll then say, we'll do the same thing. Filtered df is going to be assigned to, but this is going to be slightly different. df.filter. Then we're going to say, I believe it was pl dot-col, because we want to filter in a column. That column is going to be total cases. And then we're going to say, if I think it was is not null. Yep, is not null. Parentheses. And then we'll do the same thing. We'll go ahead and say display filtered df, run it here, and boom. Now we have only and the same thing. So it's actually a little bit cleaner to write inside polars than it is to write inside of pandas, because we're going to go ahead and just say we want to filter on the polar column of total cases where it is not null, where this is saying it's not NA. And we have to do this like extra weird filtering. You have called df twice, the data frame column, and then the actual method you want to run. This is calling the full data frame. This is calling the data frame and then the data and then the column you want to filter on. Now you have the full data frame filtered on this column and the specific method we want to filter out on. In this case, not NA. And then you're printing down. That's the difference between these two. Where this one you're just saying, hey, data frame, we want to do a filter on the polars column of total cases, and where it's not null, and show me everything that's not null. And of course, you can do the same thing we did before. And oh, I spelled head wrong. There we go. You know, the top 5 that took us 0.0 seconds to run, and running this with top just dot head took us 0.8 seconds to run. So there's definitely a increase in performance, slight increase. I mean, we're also only dealing with 394,000 records total inside this actual file, but that's a quick increase of time running. Going through all that. So that's pretty cool. These are just some cool examples of what we can do with pandas and polars. So it seems like, as we can play around with this, that polars is a little bit faster than pandas, and I happen to like the language a little bit more inside polars. Polars is also faster than pandas, because polars is actually built on Rust, where this pandas is actually developed in Python. So Rust is a up-and-coming language that is pretty powerful, very fast, handles memory very well. It's just a faster programming language. Overall, though, I think Pandas is still going to be the winner in terms of data analysis inside of Python. I don't believe that Polars is actually going to replace Pandas anytime soon, but I just want to make a video comparing the both of them and seeing how they work, how fast they work between the two, doing just basic filtering cases and whatnot. I'll have more videos out there going over more detail on how to filter and how to do aggregations, summing them, summing data, things like that. But just a cool little snippet of how to install pandas, install polars, and how to use them in a basic type means. So I hope everyone has found this useful. I appreciate you guys checking this out. Stay tuned for all my other content. Anything Data Alchemy will be on this channel. If you're looking for my gaming content, please check out all my new channel, twitch.tv/RivenPlaysGames. You can find that anywhere, any social, on YouTube as Riven Plays Games. So check out all my gaming content there. Until then, Alchemist, peace out, everyone.